this goes. So we're going to go through a couple polygons inscribed inside of a circle, trying to give some directions. We'll see how well I can go along with this. So step A, draw two diameter lines. Remember, diameters have to go through the center. So I'm just going to draw two straight lines anywhere. So there's diameter line 1. I can make diameter line 2. They have to go through the center. And they should go to the edges of the circle. Connect the 4 points to form a rectangle. I'll go from this point. Oops, let me get my straight line tool just to make it a little more official. You guys can use a ruler. So if I connect this point to this point, and this point to this point, and this point to this point, and this point to this point, I get a nice rectangle. Then it says, list the properties of the diagonals of a rectangle. All right, so the properties of the diagonals. All right, you'll notice they are congruent length because they're both diameter lines. All right, the diagonals, in case you so this diagonal is the same length as this diagonal. All right, they also bisect each other. That'll be important as we go through the year. Seeing they both go through the middle, it means this side is the same length as this side, and this side is the same length as that side. And a few other things I put in my notes here so we don't forget. This would be considered a radius line, all right, from the center to the edge, and the whole way across would be considered the diameter. Just making sure we have those words in our vocab. All right, constructing a square is going to get a little more detailed. All right, a square is a little more specific. All right, the diagonals of a square have an additional property that's going to help us out here. Diagonals of a square are perpendicular. All right. So we can start by simply drawing a diameter line. This one's a little nicer because I gave you the center of the circle. But for our second line, we can't just draw any old line. That'll just create a rectangle. We want it to be a square. So we're going to have to construct the perpendicular bisector of that line so it crosses at 90 degrees. So I can take my compass. I can put it on one end of the diameter. And just like before, to do a perpendicular bisector, you just have to go more than halfway. So I can make my arc this way. And again, you don't have to make the whole thing if you don't want to, but you can. You put the point on the other side, and I make the arc the other way. And if all goes well, I should be able to connect the intersection points through there. I'm going to just stretch this one out so it reaches the circle where I need it to. Good enough. All right, now if we connect the points, I'll make it bright and easy for you guys. So these diagonals, it's perpendicular, which makes this perfect for us. So if I connect those points on the circle together, it'll make a perfect square. And it's inscribed within the triangle. Hopefully you can see it. We got 90-degree angles at the corners, and all the sides are equal length. And we'll continue on. All right, so this one's a fun one. Let's see what I wrote down in my notes. Nothing too much. So this is just a learning thing. All right, determine the measure of each angle of the figure. So if you use a protractor, you can find each angle. There's also a formula. Again, it's from 8th grade. So you can find the measure of an angle. You can either use a protractor, or there is a formula for polygons for the sum of any polygon. You can take the number of sides minus 2, multiply that times 180, and it will give you the sum of the angles. So in this case, if we have a hexagon, there's 6 sides minus 2 times 180. So that would be 4 times 180. All right, and let's see, 720. All right, that would be the sum. And if we split them all equally for each of the angles, there's 6 angles. So we would do 720 divided by 6. All right, so each angle will be 120 degrees. All right, so this is 120, 120, 120. And you can measure that just to be sure. All right, if we connect some straight lines, connecting those guys, connecting B and D and D and F and B, what you'll notice, maybe not right away, all right, is that obviously we get a triangle. Why would it be an equilateral triangle? All right. So we know triangles add up to 180. So if it was an equilateral triangle, each of them would be 60. And then the question is, how can we prove that those are 60-degree angles? All right, well, because we know this is a regular hexagon, these sides are all the same. All right, because we know, and I'm sorry I'm not writing all this down, but you can listen to this little proof. Because we know this is an isosceles triangle, it means I know the base angles are the same. All right, and if this top angle is 120, all right, that leaves 60 degrees for these two, so each one of these is 30. And that would be true all the way around. So if we play with that a little bit, let's see if I can make this make sense. If this is 120, or somewhere along the lines of this entire angle in orange is 120 degrees. If this guy is 30, and this guy is 30, this is 60. So there's my proof that this ends up being an equilateral triangle. Maybe a little long, but whatever, it's good for you, like eating your vegetables. All right, you will enjoy this. This is the construction for creating a hexagon. The first way is what's called a radius flower. All right, so we're gonna go ahead and maybe I'll use a nice color here and go with purple. All right, and I'm gonna shrink this down a little more so we get the full effect. So when you have your compass, you're gonna put the point on the center, and basically you're going to measure the radius of the circle. So the radius of the circle, if it lets me adjust a little, hold on. Digital ones can be a little finicky. So we'll see how well I can do this. Move this in there. It's pretty close. All right, so I have the radius of the circle. So now I can place that any point I want on the circle. And I'm just going to start drawing more circles. All right, and I have my first one. I can go to my next intersection point. I can draw my next one. Notice it's going through the center because these are just radius lines. And I can keep there. Keep drawing circles. You can start to see why it's called a flower. There's many ways you could do this. I'm going with a complete circle. I think I have one more to do here. It's a little crazy. So there are shorter ways, but it's a very pretty way. All right. What you get, all right, is lots of petals. But if you connect these little nice intersection points that were created, you will get a perfect hexagon. All right. So there's so many lines there, you might get a little lost in it, but it is a fun little construction. All right. I'm just going to reiterate this, and I'm going to make these lines a little extra wide for a second. So the hexagon is right here. And this is a dual purpose because you can construct a hexagon, and if you wanted to, all right, we can also construct a flower. Trying to do something, or construct an equilateral triangle, because if we connect every other one, all right, that gives us our equilateral triangle. So it's kind of a multi-purpose construction. Sorry for all the crazy lines, but use some colors, make it fun. All right, there is a little shorter method you can do if you have the center. So method 2, the diameter and radius method, you can start by just drawing the diameter line in the circle. All right. From here, we can then measure the radius. There we go, right at the center. And I can simply draw an arc here. And if I go to the other one, I can draw an arc here. It goes through the center. And get rid of that extra line. And then you can connect the dots this way too. So I can connect this point. This guy's getting in my way. That point. That point. That point. That point. Back to here, guessing my way through this box. There we go. So it's not as messy. You can do it with less lines, just drawing that diameter line and then the radius arcs and connecting them. You can get your hexagon, and again, you can make an equilateral triangle too. All right, and then it's just practicing what we did. All right, then you can do some practice. Number 1 is trying to do your own inscribed square. Number 2 is a challenge. All right, trying to create the shape that you see there. That's completely optional.